The dwarf planet that dismantles the Planet 9 existence theory. For years, astronomers have searched for a giant planet hidden in the far reaches of the solar system, a supposed Planet 9 that would explain the strange orbits of some distant objects. But what if everything was based on a wrong assumption? Recently, the discovery of the dwarf planet 2017 OF201 has sown a monumental doubt. Its orbit not only challenges the hypothesis of Planet 9, but could be the definitive proof that it never existed. Does it mean that the search for Planet 9 has just ended? What does this mean for modern astronomy? Keep watching the video. We'll explain it to you. Beyond Neptune, in that icy and distant region that we are just beginning to understand, thousands of bodies orbit that are part of the Kuiper Belt and even more remote Oort cloud. For a long time, these objects were considered mere relics of the early solar system, but something in their orbits began to arouse suspicion. As astronomers gathered data, they noticed a curious phenomenon. Several of these trans-Neptunian objects, or TNOs, appeared to share certain unusual orbital features. It was not a coincidence, or at least that's what they thought. Some of these extremely distant bodies had elliptical orbits, very elongated, with their perihelion, the closest point to the Sun, grouped in the same sector of the sky. In addition, their orbits were inclined similarly concerning the plane of the solar system, and many of them seemed to point in similar directions, as if they were all synchronized by the gravity of an invisible object. This orbital pattern was especially striking because, according to the laws of celestial mechanics, a group of objects so far away and small should not spontaneously show such alignment. Their distribution should be chaotic, scattered, determined by random influences, and by the gravity of known planets. However, that was not what the data showed. It was then that the first conjectures arose. What could be keeping these objects in such strange and consistent orbits? And why did they share such specific characteristics, such as a high eccentricity or similar orbital orientation? Astronomers were faced with a dilemma. Either there was something fundamentally wrong with their models of the outer solar system, or there was a hitherto undetected gravitational factor influencing those bodies. And so, from these seemingly innocent questions, one of the most intriguing hypotheses in modern astronomy was born: the possible existence of a ninth planet hidden beyond Neptune. But at this point in history, there was not yet a Planet 9. There was only one orbital mystery, a recurring pattern in the far reaches of the solar system that the 8 known planets could not explain. This pattern would be the spark that would ignite the scientific imagination and mark the beginning of a search that, to this day, continues without conclusive results. Planet 9 hypothesis. The Planet 9 hypothesis was born out of a particular need to explain the apparent order and the chaos of the outer solar system. In 2016, 2 astronomers from the California Institute of Technology, Konstantin Batygin and Michael E. Brown, published a study that would significantly alter the conversation in the scientific community. According to their calculations, this pattern in the orbits of some extremely distant TNOs could only be explained if there was an object of great mass, the size of Neptune or even larger, that was gravitationally perturbing them from the shadows. This object, which was soon dubbed Planet 9, would have a mass between 5 and 10 times that of Earth, and would be in a highly eccentric orbit with an average distance from the Sun of more than 400 astronomical units. To put it in perspective, that's more than 10 times the distance between Neptune and the Sun, a region so far away and dark that even the most powerful telescopes would have a hard time detecting a planet, mainly if it reflected little sunlight. But why take this hypothesis so seriously? Because it was backed by someone who had already revolutionized the study of the solar system, Michael E. Brown. This astronomer is known for having discovered Eris, the dwarf planet whose detection led to the reclassification of Pluto as a dwarf planet in 2006. His record as a hunter of distant worlds was impeccable, and his reputation unblemished. So when he and Batygin claimed that there must be a ninth planet, the world listened to them. According to their study, this Planet 9 would not only explain the grouping of perihelions, but also the inclination of the orbits and the existence of some objects with trajectories perpendicular to the plane of the solar system. Everything seemed to fall into place. In a short time, the astronomical community turned its attention to a new planetary hunt, utilizing ground and space-based telescopes, modeling possible trajectories, and publishing hundreds of papers to analyze their implications. But the years passed, and Planet 9 still didn't appear. Neither the Subaru telescope in Hawaii, nor the instruments of the European Southern Observatory, nor the Hubble Space Telescope were able to find the slightest direct evidence of this object. Some regions of the sky, especially those near the galactic plane, were difficult to explore due to the large number of stars blocking visibility, and some proponents suggested that it might be hidden. However, other scientists began to raise their voices. What if Planet 9 did not exist? What if that orbital pattern could be explained in another way? What if, as in the case of the supposed planet Vulcan in the 19th century, we were inventing a celestial body to explain phenomena that had another origin? These questions were not mere skepticism, but the germ of new ideas that would test the robustness of the Planet 9 hypothesis. And soon, some data would begin to suggest that perhaps the orbits of those objects were not as compatible with the existence of a hidden giant planet as previously thought. Hey guys, just a moment before we continue. Don't forget to subscribe to our channel clicking on the notification bell and leave us a thumbs up so you don't miss out on our daily videos. TNOs and ETNOs, first indications that there was no Planet 9. As more telescopes scoured the edges of the solar system for clues, astronomers began to discover new trans-Neptunian objects, some of them even more distant and strange than the first 6 used by Babbage and Brown in their initial formulation. And here, an unexpected problem arose. Several of these newly discovered objects did not quite fit the predictions of the Planet 9 hypothesis. According to the proposed model, a giant planet exerting its influence from the outskirts should cause the orbits of TNOs and ETNOs, extreme trans-Neptunian objects, to align in specific directions, present similar inclinations, and show perihelion clustered in a narrow sector of the sky. However, as the sample increased, exceptions began to appear. Objects with opposite perihelions, incompatible inclinations, and even trajectories that crossed regions where, according to the hypothesis, they should have been perturbed or ejected by the supposed Planet 9. In addition, another bias became evident. Most of the TNOs discovered had been found in areas of the sky that telescopes can observe more easily, that is, in regions less contaminated by stars or galactic dust. This raised a fundamental question. What if this apparent orbital grouping was not real, but a consequence of the limitations in our observations? What if what we were seeing was just a statistical illusion caused by the methods with which we explored space? Several studies began to review the validity of the orbital alignment proposed by Babbage and Brown. Some concluded that by including more objects and correcting for observational biases, the pattern was not as clear as it seemed. Specific simulations showed that the observed orbits could arise without the need for a massive planet. It was only necessary to correctly consider the interactions between multiple TNOs, the galactic gravitational field, or even a disk of matter scattered in the outer solar system. Most alarming to the proponents of Planet 9 was the appearance of objects that, instead of being affected by a force that kept them in order, showed the exact opposite. Trajectories that defied any large-scale external gravitational influence. Not only did these bodies not obey the model of Planet 9, but in some cases, if that planet had existed, they could not even remain stable in their current orbits. This was the turning point. The scientific community began to divide between those who still believed that Planet 9 was out there, hidden in the vastness of space, and those who thought that perhaps it just never existed. And just when the debate seemed to be stalling, a new protagonist made his entrance. A dwarf planet so eccentric, so peculiar, that it put the whole hypothesis in check. 2017 OF201. Its name may sound unexciting, almost bureaucratic, but its existence has been a real jolt to the study of the outer solar system. Discovered in 2017 by the Outer Solar System Origin Survey, or the OSSOS project team, the small but powerful dwarf planet has challenged one of the most compelling hypotheses in contemporary astronomy: the existence of Planet 9. To understand why this project is so special, you first have to look at its orbital characteristics. 2017 OF201 has a highly eccentric orbit, meaning it is very elongated. Its affiliate, the farthest point from the Sun, is more than 800 astronomical units, or AU, while its perihelion, the closest point, barely exceeds 35 AU, temporarily placing it closer to Neptune for part of its journey. This eccentric and extended orbit means that its journey around the Sun takes thousands of years. A single year in 2017 OF201, i.e. a complete circle of the Sun, is estimated to last approximately 20,000 Earth years. Another key fact: its orbit is highly inclined, notably separating from the plane in which most planets orbit. This kind of tilt is just what many astronomers were looking for when exploring the possible effects of Planet 9, as one of the arguments in favor of its existence was the presence of objects with inclined orbits and clustered perihelions. However, 2017 OF201 does not only fit that pattern, but it also directly contradicts it. Its discovery was made with high-precision telescopes capable of detecting slow-moving objects at great distances from the Sun, something that was almost impossible until a few years ago. Its detection involved careful analysis of hundreds of images taken over weeks, tracking the tiny displacement of an almost imperceptible point in the sky. And it's precisely that difficulty that makes this finding so valuable. Every new object discovered in these regions has the potential to rewrite what we think we know about the architecture of the solar system. But beyond the numbers, what has made 2017 OF201 famous is what its orbit implies. According to various computer models, this object could not exist if Planet 9 were out there. In other words, simulations that include a hidden giant planet in the solar system can't produce an orbit like that of 2017 OF201. Its trajectory, inclination, and distance are incompatible with the gravitational influence of a massive ninth planet. Instead, when you strip away those hypothetical influences and consider only the 8 known planets, plus the natural perturbations of the solar system, the orbit of 2017 OF201 makes sense. It is stable, it's predictable, it is coherent. This made the tiny and unshowy 2017 OF201 a key piece of the elusive Planet 9 puzzle. Not because it was the most massive, nor the most distant, nor the brightest, but because its mere existence calls into question the need for Planet 9 as an explanation for orbital anomalies. If an object like this can exist without the need for a ninth planet, maybe everyone else can too. Goodbye to the Planet 9 hypothesis. The discovery of 2017 OF201 not only contributed a curious fact to the catalog of trans-Neptunian objects, it became a real thorn in the side of the Planet 9 hypothesis. To understand why, you need to go beyond its eccentricity or inclination and focus on how it would interact with the gravitational environment if such a hypothetical giant planet existed. Orbital studies on 2017 OF201 have been rigorous. Researchers have used computer simulations that model the solar system in different scenarios, one with all 8 known planets and one with Planet 9 included, following the characteristics proposed by Badigian and Brown. The result was overwhelming. When a planet of between 5 and 10 Earth masses is incorporated about 400 or 500 astronomical units from the Sun, the orbit of 2017 OF201 simply does not survive. It becomes unstable, is ejected, or its trajectory is deformed until it loses the observed characteristics. Instead, when the model is limited to the 8 known planets with no 9th hidden planet, the orbit of 2017 OF201 remains completely stable for millions of years. Its eccentricity, tilt, and current position makes sense within the gravitational framework of our solar system as we know it. This implies a logical consequence that is difficult to ignore. If Planet 9 existed as described, 2017 OF201 could not be where it is. And this is not an isolated anomaly. This object is empirical evidence that directly contradicts a fundamental prediction of the Planet 9 hypothesis. It's not just that it doesn't fit into the expected orbital pattern, it's that it refuses the mechanism by which that pattern supposedly originates. The importance of this finding has divided the scientific community. Some astronomers still maintain that there may be an unknown planet out there, but propose that its orbital parameters could be different from those originally proposed. Others, on the other hand, are beginning to abandon the idea of Planet 9 altogether, considering that phenomena such as the collective influence of many objects, or even disturbances from outside the solar system, could explain the observed anomalies without the need for a hidden giant planet. 2017 OF201 has thus become a key object in rethinking what we understand of the outer solar system. Its existence not only weakens the Planet 9 hypothesis, but also reinforces the idea that our theories must adapt to the data rather than the other way around. In a universe as vast and uncertain as ours, even a small dwarf planet can have the power to dismantle a big idea. The universe never ceases to amaze us. Sometimes it's not a giant planet or a spectacular phenomenon that changes the way we see the cosmos, but a small, silent object lost in the darkness. 2017 OF201 reminds us that even the most seductive theories must submit to the relentless judgment of evidence. And in this case, perhaps the real mystery is not whether Planet 9 exists, but why we ever thought it should. And what do you think? Are we chasing a shadow, or is there still something beyond Neptune waiting to be discovered? Let us know your thoughts in the comments below. And if you like this video, then you should check out this video on our end screens.